Welcome back to day 3 of our Unit 1 in Algebra Regions. All right, our goal for today, given a word problem, you will be able to solve for unit conversions using equivalent ratios. Now, I'm going to let you know right now, today's lesson is going to be just a little bit challenging, but pay attention, take your time, and you should be able to accomplish our goal. All right, let's jump right into it. In order to achieve our goal today, the first thing we have to do is review the idea of ratios. Now, a ratio can be used to compare two or more quantities. All right, we can say, for example, if there is one boy and 3 girls, we can write it as a 1 to 3. For every one boy, there are 3 girls. We can say a fourth are boys and a third are girls because the total is 4. All right, we could say 0.25 are boys, or we could say 25% are boys because we can always multiply a decimal by 100 to get to your percent. All right, so let's take a look at our first question to review ratios. So here we have 9th graders at Amherst High School took a survey on their favorite cafeteria lunch. Below is a table of their results. So here we have our items, boys, and girls. Now, I'm sure in our heads we're all picking out what our favorite food is. However, let's take a look at the first question. Which item was the favorite lunch menu and why? So if we take a look here, it's really hard to see which item was the favorite because we've separated out girls and the boys, and their individual favorites are quite different. So what I'm going to do is I'm going to go over here and I'm going to add another column, and I'm going to call it my total column. So I'm going to go ahead and add the boys and the girls together. So hot dogs, the total that like hot dogs, 22. The total that like tacos, 56. The total that like pizza, 55, and the total that like turkey and potatoes is 17. All right, so which item is the favorite? Well, I can see very easily now that the favorite is taco. Okay, and how do I know that? So whenever you see the word why, that means we have to write because and explain how we know. Because it had the most votes. All right, now, if I were part of the survey, I probably would have picked pizza because that's my favorite. So let's take a look. What percent of the students chose pizza as their favorite? So let's take a look. So we want a percent. To complete a percent, you need part over total times by 100%. So let's take a look. What part of the surveyed liked pizza? That was 55. Now, do we have the total number of people in the survey? It doesn't tell us, so we're going to have to add it up. And if we add all of these together, we get 150. So my total is 150. Then I'm going to multiply that by 100. So let's go ahead, take out your handy dandy calculator, and let's multiply it out. So 55 divided by 150 times 100. And we get a grand total of 36.6 repeating percent. Now, it didn't tell me to round, so I'm going to write the whole thing out, 36.6 repeating percent. All right, so there's our first example. Let's go ahead now. Let's take a look at another example where we talk about rate. So during the winter of 2012 to 2013, Buffalo, New York received 22 inches of snow in 12 hours. Oswego, New York received 31 inches of snow over 15 hours. Which city had the heavier snowfall, and explain? All right, most of us like to think Buffalo always has the heaviest snowfall, but we need to find some data to actually figure that out. So here it says, which city had the heavier snowfall rate? So rate is when you do amount over the time. So let's go ahead and figure out the rates for Buffalo and then the rate for Oswego, and then we'll be able to figure out which one had the heavier snowfall. So here we go, Buffalo and Oswego. Now if we go back to the problem, it says Buffalo received 22 inches in 12 hours. So I'm going to go 22 over 12 hours. And if I take that and plug it in the calculator, 22 divided by 12, it's 1.83 repeating. And then it would be inches per hour. Now let's take a look at Oswego. So they're 31 inches. over 15 hours. So we plug that one in, 31 divided by 15, we get 2.06 repeating inches per hour. So who had this heavier snowfall? Oswego. Because their rate of 2.06 inches per hour is greater than Buffalo. So we found our answer, and then we explained why it worked. All right, so now that we've reviewed a little bit about ratios, rates, percent, now we're going to take a look at the main idea for today's lesson, which is our unit conversions. Now, unit conversions is where we can change units from we can change different quantities, we can change the units of. So we could change inches to centimeters, pounds to ounces, gallons to quarts, okay, using these different conversions. Now, there are a few conversions that you do have to memorize on your own, and they are these over here. So let's go ahead and write these ones down. So 1 year equals 365 days. 1 year is 12 months. 1 yard is equal to 3 feet. 1 hour is equal to 60 minutes. 1 minute is 60 seconds. 1 dozen is equal to 12. And the one that I forgot to put on here was 1 foot equals 12 inches. So these are all of your different conversions, and these are going to be what's going to help us within our problems. So let's go ahead and take a look at the first one. There are 8 ounces in 1 cup. If Joanna has 20 ounces, how many cups does she have? Okay, so what we're going to do is you always start with whatever they give you in the problem. So here they're starting with 20 ounces. So I'm going to write 20 ounces. Now, to convert this, I'm going to use what we call an equivalent ratio. So I'm going to multiply this by a fraction. And that fraction is going to be an equivalent ratio. So it's going to use one of these conversions, or in this case, they gave us the conversion right here, 8 ounces in 1 cup. Now, when I put that into the ratio, I have to put it in there very carefully because I want to make sure that I cancel the ounces because I want to end with cups. They want me to convert it into cups. So here I have 8 ounces. I'm going to put 8 ounces on the bottom. And 1 cup. It's equal to 1 cup. So 1 cup equals 8 ounces. We're starting with 20 ounces. If I want to, I can put that over 1. And now it's very easy to see that the ounces cancel with the ounces. So now what's the only unit we have left? Cups. So now we have 20 over 8 cups. Or we can divide that, 20 divided by 8, and it's 2.5 cups. Okay, let's try another one. So let's take a look at number 2. Christian has a rope that is 1.2 yards. How many inches does he have? So we're starting with yards. We want to end with inches. So let's look carefully. Do we have a conversion that goes from yards to inches? I don't see anything that goes yards to inches. Okay, not here, not there. If I look over here, I have yards to feet. And then I have feet to inches, so I could do it that way. We're going to have to do 2 conversions here. We're going to have to go yards to feet, and then feet, we can convert it then to inches. Okay, so let's start with what we have. We have 1.2 yards. I'm going to put that over 1. That's what we're starting with. Now, I'm going to multiply that by an equivalent ratio. So let's look. We want to change it to feet. So my equivalent ratio, 1 yard, is 3 feet. So I need to put that into a fraction. I want my yards to cancel, so I'm going to put 1 yard in the bottom, and then that's equal to 3 feet. So now I can cancel yards and yards, and I'm left with feet. So now I'm going to multiply across. 1.2 times 3, we get 3.6 feet. Now I'm going to take my feet and I'm going to convert it into inches. Oops, look like it's not focused here. All right, so let's go ahead. Then we have 3.6 feet over 1 times, now 1 foot is 12 inches. And I want to cancel the feet, so I'm going to put feet in the bottom. So 1 feet, or 1 foot, and 12 inches. So my feet cancels with the feet, and 3.6 times 12, and we're going to get 43.2, and my units are inches. And we got it. All right, let's go ahead then and let's take a look at number 3. It took Danica 540 seconds to run around the park. How many hours would that be? So here we're converting seconds into hours. So let's take a look up here. Do we have seconds into hours? All right, we don't have seconds into hours, but we have seconds into minutes and minutes into hours. So here again, we're going to have to do 2 conversions. So we're going to go seconds, and we're going to convert it to minutes, and then we can do minutes and convert it into hours. Okay, so let's start with what we have. We have 540 seconds. So 540 seconds over 1. Now I want to multiply that by my first equivalent fraction. So let's think, how many seconds are in a minute? Well, there's 60 seconds in 1 minute. So I need 60 seconds in 1 minute. I'm going to put 60 seconds in the bottom and then 1 minute in the top, because by doing that, my seconds are going to cancel. And that leaves me with 540 all over 60 minutes. But I can divide that, 540 divided by 60, and that's actually going to be 9 minutes. Now, we have to take minutes and convert it into hours. So I'm going to start with 9 minutes over 1 times. Now, I know that there's 60 minutes in 1 hour, so that's my equivalent fraction. So now I have to figure out where I'm going to put each number. I'm going to go 60 minutes on the bottom, 1 hour on the top, because now the minutes on the bottom cancel with the minutes in the top. And we have 9 over 60, and I can divide that out, 9 divided by 60, and we get 0.15 hours. And we've just converted. Okay, up next, Jared ran 1 mile in 6 minutes. What is his speed in miles per hour? So I want to I need 2 measurements here. I need miles and hours. So let's look at what we start with. We start with 1 mile. So miles and miles, those match. 6 minutes, hours, those do not match. So the first thing we have to do is convert minutes into hours. So let's go ahead and do that. I'm starting with 6 minutes. Now I have to set up my equivalent fraction. Sometimes we'll see it in parentheses. Okay, so I know that there are 60 minutes in 1 hour. I want minutes to cancel, so I put the minutes in the bottom and 1 hour. So the minutes cancel with the minutes, and I get 6 over 60. I'm going to divide that out. 6 divided by 60, I get 0.1 hours. So now I have hours in miles. So my speed, we want miles per hour. So I'm going to plug it in. I know my miles is 1 mile. That's what he ran. He ran 1 mile, and he ran it in 0.1 hours. So let's divide it out. 1 divided by 0.1, he ran at a speed of 10 miles per hour. All right, last question. I'm going to start with you, okay, and eventually the video is going to stop, and I'm going to have you finish on your own. Okay, so number 2. Dan took 2 minutes to run 440 yards. What would his speed be in miles per hour round to the nearest tenth? So here we want miles per hour. So here we have yards. We have to convert it into miles. Minutes we have to convert into hours. So go ahead. I'd like you to go ahead and try those. Okay, so if you look, we should get hours miles. We put it into speed and we get 7.5 miles